Hey Panthers, I want to apologize up front here. I am recording this in the library and there are some students in here, so hopefully you can hear me. We are going to take a look at section 9.3, which is the area of parallelograms. Say that with me, area of parallelograms. And if you could make sure you have a calculator in front of you, that would be great. And let's go ahead and get started. Our learning target for today is that you will learn to find the area of rectangles and parallelograms. Just to recall, remember rectangles, opposite sides are parallel, opposite sides are congruent, and it forms four 90-degree angles. And parallelograms, opposite sides, it's a quadrilateral, four-sided shape, opposite sides are parallel. We are going to be finding the area. We've talked a lot about area this year, and we've talked a lot about it being a two-dimensional measurement. But the area is the number of square units needed to cover a figure. Okay? The number of square units needed to cover a figure. So go ahead and put that into your notes. So we're looking at two figures here, rectangles and parallelograms. Now rectangles, finding the area, I know you are very familiar with. You find the area by doing the length times the width. So if we take a look at this rectangle, we have the length and we have the width. Please go ahead and label those. And let's count how many square units let's count how many square units the length is. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if we go back here, L is 10, or the length is 10, and the width is 1, 2, 3, 4, 5, 6. So W is 6. So we have length times width, and this is a total of square. Let's go ahead and use, we'll just put the word units because we don't have any labels here. And if we solve it, Panthers, 10 times 6 is 60 square units. And we abbreviate this by writing out our units and using a 2 as an exponent, showing that we are squaring our units. Remember, area is a measurement, a two-dimensional measurement, so we square all of our units. Now, parallelogram doesn't necessarily have length and width because sometimes they can be a little bit slanted. So we use a very similar formula, but we use area equals base times height. Now, base is going to be a base of a parallelogram is always one of the parallel sides, and the height is the distance from one base to the other. Now, some students get confused because they see this line here and think that is the measurement of the height. Now, Panthers, have you ever slanted your body and taken your height? You can't do it. It's not the same. So the height is the distance from one base to another, and that's where this formula changes a little bit. I want to show you something cool. If I were to cut off this triangle here and move it over here, I just created a rectangle. Okay, so we can manipulate this shape. That's why we get a very similar form when we use base and height. So here, Panthers, our base, let's count. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And our height, 1, 2, 3, 4, 5, 6 again. So once again, we have 60 units, and then we're going to square them. 60 square units. Okay, let's take a look at some examples. The first one, we're looking at a rectangle. And again, we've been talking a lot about formula. So we are going to write down our formula every step of the way. Remember the formula, find a rectangle for area is length times width. So let's go ahead and fill in. The length here of our rectangle, we have 7 4/10, and we're going to multiply that by the W, or the width, which is 4 1/2. And when you go ahead, Panthers, grab your calculators. Go ahead and type in 7 4/10 and multiply it by 4 5/10. And you should get 33 3. Our units here are inches. And what are we going to do with all of our units when we talk about area? We are squaring it because it is a two-dimensional figure. Okay, letter B. And again, this should be pretty, this should be somewhat of a review for each of you. Once again, we're looking at a rectangle, so we're going to pull out our rectangle formula, length times width, and let's plug it in. Our length of our rectangle is 21 1/2. We're going to multiply that by our width. Width is 9 1/10. And grab your calculators. When I multiply this out, you should get 195 and 65. What are our units? We have centimeters, and because we're talking about area, it's centimeters times centimeters, or centimeters squared. Example 2. We're looking at a story problem. It says the area of a playing field is 1,470 square feet. So this time we're given the area. And the length is 42 feet. What is the width? So here, Panthers, again, we're talking about a playing field, so it's a rectangle. Let's pull out our formula. The area of a rectangle can be found by doing length times width, and let's plug in everything we know. Now this time we know that the area is 1,470. Do we know the length? We do know the length. It is 42. Do we know the width? We do not know the width, so we'll use our variable of W. And we use our equation steps. W is being multiplied by 42, so we're going to divide by 42. And if I do it to one side, I must do it to the other. Grab your calculators. Therefore, W must be 35 feet. Now, Panthers, should I square that? I hope that you're saying no. Width is just a one-dimensional measurement. Same thing with length, but when I multiply width times length, then it becomes a two-dimensional measurement. So please remember when you're solving these problems, if you're solving for area, your units are squared. If you're solving for length and width, your units are not squared. Okay, let's take a look at some parallelograms. Now remember, I could manipulate these shapes and change them back into a rectangle, but no need to do that. We will just switch up our formula a little bit, and we're going to now use the formula instead of area equals length times width. Since our width is kind of slanted, we can't really get a good measurement of it, we're going to use base times height. And let's plug in everything we know. What is the base? We have 16 meters. Multiplied by our height. Again, the height is the distance from one base to another. We have 8. Grab your calculators. 16 times 8 is 128. Our units are meters, and because we're solving for area, we are going to square our units because it's meters times meters. Moving on to letter B. Again, we have a parallelogram. So we're going to use the formula base times height. Let's go ahead and plug in everything we know. Here again, we're using the base up top. It doesn't matter where you go. Remember, the bases have to be parallel sides. This base is 3 2/10 meters multiplied by the height. 1 and 4/10 meters. Grab your calculators. 3 and 2/10 times 1 and 4/10 is 4 and 48 hundredths. Our units are meters, and because we're solving for area, we are going to square our units. Okay, Panthers, last one, example 4. This is a little tricky. Now, we've spoken in the past. Whenever you can draw a picture to represent your story problem, please do that. Let's go through and cube this. Okay. A carpenter is covering a 150 square foot floor with square tiles that are each 2 feet in length. What is the least number of tiles the carpenter will need to cover the floor? Well, let's take a look at this. First, the entire area is 150 square feet, so in order to get that, we must have multiplied length times width. Now let's focus on these square tiles. Go ahead and draw a square. If we know the length is 2 feet, Panthers, could you tell me what the width would be? What would the width be of a square tile that has a length of 2? The key word here is that what shape are the tiles? They are squares, which means all 4 sides are congruent. So the area of one tile is length of 2 times width of 2 is 4 square feet. Whoops, 4 square feet. So Panthers, if we are covering a total area of 150 square feet, and I know each tile is 4 square feet, let's go ahead and divide this to figure out how many tiles I will need to cover the entire area. Grab your calculators. 150 divided by 4, we get 37.5. And what are we solving for? What is the number of tiles? Okay, Panthers. This concludes our lesson. Hopefully you understand now how to find the area of rectangles and parallelograms. Have a good day.